research. High or low tech, these scientific observations arm experts with knowledge they didn't have before. They prove useful in another way. They help put to rest some misguided beliefs about earthquakes that have been perpetuated for years.
Myth number one, California will fall into the ocean. This doesn't happen because the San Andreas is a vertical fault. One side moves past the other sideways. So nothing is falling anywhere.
Myth number two, earthquakes occur more frequently in winter than summer, and in the morning as opposed to night.
Quakes happen any time of the day or night, any phase of the moon, any time of the year. There's really not any statistical preference.
We've done numerous studies looking for correlations with time of day, tides in the earth. The results seem to be that there's either no correlation or the correlation is so weak that it's not really worth mentioning. Remember, these earthquakes are starting 10 miles down in the rock, so it's kind of hard to think that at 10 miles deep in rock that you know anything about what the weather is at the surface of the earth.
Myth number three, animals can predict earthquakes.
When somebody calls up and said, my animal was behaving strangely before an earthquake, what do we do with that information? It's not objective information. Anecdotally, we know it's not true. Animals behave strange all the time.
These notions are embraced because they offer simple explanations to complex problems that have confounded experts for years. For all their knowledge, scientists can't predict the size or timing of earthquakes. The best they can do is determine where they are likely to occur and at what rate.
I can tell you there'll be 50 every day. There'll probably be 30,000 this year. There'll probably be 1 magnitude 5 this year somewhere in California. I just don't know where in California or which one.
And it's what researchers don't know that's the focus of future study. Just when they think they've nailed an idea or a constant, the Earth throws them a curve. Like the planet itself, scientists are continually adapting and adjusting. Technology has advanced to such a degree that earthquakes can be realistically recreated. This attraction at Universal Studios simulates what it's like to be in a quake, a big one. But only in Hollywood, the land of make-believe, is the experience fun. Someone's at the controls in this disaster, determining when the shaking starts and when it stops.
And just when you think it's over, 60,000 gallons of water come crashing down. People love it. They're screaming, they're clapping, they're cheering. Some people even get a little bit wet, but hey, that's what it's all about.
Choreographed to the second, there are no deaths or actual damage. If only it were that way in the real world. The Earth and its complex nature continues to baffle the experts. The holy grail of quakes, prediction, has so far been elusive. It will likely remain one of the great mysteries of all time.
It's clearly a long ways away. Nothing we've ever looked for has ever worked. And there's these theoretical issues. We don't know what controls the size of an earthquake. And until we get that, I don't think we can have a chance at the prediction.
It's a very, very difficult problem and maybe impossible.
But knowing exactly when one earthquake will happen is still a very difficult problem. That'd be very valuable to know the answer to that question.
Technology is the best hope.
We would like to be using supercomputers and computers maybe that are 100 to 1,000 times faster than what we have today.
Computers operating at the speed of light would allow for an early warning system, not weeks or days in advance, but seconds before the waves of a quake reach populated areas.
We could have an automatic warning of 15 seconds or whatever. And it doesn't sound like much, but if you stop elevators at a floor or stop hazardous material operations, shut down nuclear plants, that kind of thing, save a lot of lives.
We could prevent some serious losses, we think, by ringing alarms in places where toxic materials are handled. Don't be in the middle of pouring out a vat of chlorine when the earthquake hits. That's where something where just a few seconds could make quite a bit of difference. Operating rooms. Have it so the surgeon doesn't have the scalpel in your body when the shaking comes through.
The technology to implement such a system is almost there, but funding isn't. Due to its cost, early warning may not be a reality for many years. Another snag involves science. How to know which of the Earth's movements are significant enough to warrant an alert.
We can't tell the difference between the beginning of a 2 and an 8. So since we get thousands of magnitude 2s a year, does it mean that we have to predict every one of the magnitude 2s and then predict which of those 2s will turn into an 8?
Here's what the experts in computer technology can do. Deliver information to the public more quickly than ever before. Specifically, the exact location of a quake.
50 years ago, we gave it to you 12 hours after the earthquake. We're down to 1 or 2 minutes.
Shake maps are available on the internet. They can be accessed by anyone at any time. Rescue crews, for example, can see right away where an earthquake is centered and where help might be needed most.
After the quake, we just have to wait for all the waves to be recorded at the stations. The computer automatically locates the quake, assigns a magnitude, updates the website, and sends out pager information for us and so forth.
Today, it's like we're in the rocket age. We can go to the moon with things. Everything can be done automatically. And so the number of people that are required are much smaller, and the amount of technology we used in order to save people is tremendous.
Unlike science conducted in a test tube or petri dish, earthquake research involves a unique problem. Scientists have to wait for the Earth to move, while simulations and recreations contribute to an overall understanding. The true nature of quakes is known only after they've really occurred. It's why the hole at Parkfield, California holds so much hope.
At Parkfield, we can go back to an earthquake in 1857, a foreshock of a great earthquake. The great earthquake we call the Fort Tejon earthquake that ruptured more than 200 miles of the San Andreas Fault, and it began with an earthquake of about magnitude 6. Well, that foreshock, we believe, has been a repeating earthquake at Parkfield. The same earthquake happened in 1881, no big earthquake afterwards. Again in 1901, 1922, 1934, 1966. Well, there's a pattern apparently. And based upon the pattern, in the mid-1980s, scientists suggested that there should be another earthquake in about another 22 or 25 years. We're a bit overdue now. We expect that one will occur in the coming decades.
Of course, they can't know that for sure, but they'll be ready if and when it comes. They'll measure the forces that act on the fault, the physical and chemical processes of an earthquake.
They do put sensors down the hole, which are seismometers, in a string, so they have a lot of them that can measure the earthquake waves in different layers. They do also put in cameras to look at the cracks that are in the wall of the hole, because the crack patterns tell you something about the state of stress in and around the hole. And they do also pump fluids into the hole to try to break the wall of the hole to see what forces are being applied to the hole in the region.
The drill is linked to a computer that tells workers the depth of the hole. Samples or cuttings of rock are collected every 100 feet and analyzed. Most important, the hole is being drilled into the heart of a future earthquake. Scientists will be able to see it as it happens from an observatory deep within the fault.
We've built up an understanding that allows us to target this one place where we know this one earthquake will continue to occur.
The project is long-term, 5 years. Drilling will be completed in several stages. There are no guarantees except this. For the first time ever, researchers will have a window on a quake.
It's an amazing age we live in. We've put men on the moon. We've made rapid advances in biological fields, cloning. Everything seems possible.
Almost everything.
I have to remind everybody that some things are impossible. We're not going to stay alive forever unless something happens tomorrow that changes us. And I think earthquakes may be one of those things that we're not going to stop either.
If there's one thing scientists have learned, it's this: even technology has its limits.